Hi there, and welcome to another episode of Translating Technobabble. My name is Gary Schultz, and today we're going to be talking about automated testing. And with me today is Gleb Bahmutov. He is the Vice President of Engineering for Cypress.io. Gleb, I'm so glad you're here.
Hi, Gary. It's good to be here.
This is something we've been wanting to talk about for a while. I think it's something that's often, I'd say 80% of the conversations I have with engineering managers, directors, vice presidents of engineering, guys running massive teams. And I ask about code coverage and testing, and it gets really quiet sometimes. And it's something that everybody knows they need to do, but it seems like there's just not a discipline around it. And I'm excited to be able to talk about this today. So let's just get right into it. What is automated testing?
I'll start with what it's not. It's not manual testing. So many companies, they write great software, but the way they deliver the software after it's written to the customer requires a manual step. So many years ago, I used to work for MathWorks, the makers of MATLAB, great product. And we were porting its UI to run on the web. And every 2 weeks, we had this period, a couple hours where we all got together. We all went into the same room and we banged on the application running in a browser just to see if there are any bugs, any regressions. We mostly concentrated on new features, but we also kind of had a script to go through all the existing features. And that's a manual testing, right? It's something that you have to remember to do before you actually show it to the customer. And that's such a pain that many people are trying to avoid it. And unfortunately, they avoid it by dropping testing altogether. But lately, the tooling has improved. We always had great tooling for writing small unit tests. But that's not enough. It's not the same as you using the software as a final, ultimate user. But now the tooling caught up, I believe, and many programs like I'm working on one, Cypress, that tooling allows you to automate those steps. So automating testing replaces the manual script saying, open the website, click on a button, make sure a pop-up appears, with a script that does the same thing, but it's run automatically by software. So you can run it a lot more. You can run it on every commit. You can run it in all permutations. And that's great because you can build a library of those tests that you run automatically and nightly before each release, however you want. And those scripts never make mistake, never get tired, never get confused, right? They actually allow you to deliver good software. So that's automated testing, in my opinion.
I think it's really important for us to step back and refresh on kind of the suite of tests and what they are. Is that fair?
That's absolutely fair, right? And I would call them different types of tests. You can do many things, but I think the most popular that can be automated right now are unit tests, component tests, integration tests, API tests, end-to-end tests, and visual snapshots. So let me define each one. So there are unit tests, right? It's when you test the smallest piece of code. It could be a function, right? If you wrote a function that adds two numbers, when you call this function with 2 and 3, does it return 5? So that's a unit test. There are excellent tools in every language and for every environment that can run unit tests quickly and easily, right? So I think that problem has been solved for a while. That's why many developers write a lot of unit tests. But when you think about the web, and the way modern web applications are written, they don't operate on functions. Instead, they build the UI out of components. And each component can encapsulate a small piece of a web application. So if you have, let's say, a Sudoku application, you can have a board component, you can have a status component, and status component can have maybe a timer component under it. Maybe it can have numbers component. Maybe it can have a component that shows who won the game. Maybe there is component for different modes. So the whole application is kind of like a tree of components. So this is the way modern applications are written. Now, if you write your application out of components, you probably want to test them individually before you put everything together. So there are component tests. After component tests, you have integration. That's where you start putting individual pieces of a puzzle together. And just like a good puzzle or a Lego block, it has to fit with other puzzle pieces. And a lot of times you'll find, well, what we've written in my team doesn't fit with what you've written or what I've written a month ago, right? Like the way we call each other doesn't work. It was maybe underspecified, or we understood them completely different ways. So the integration test is where you start putting things together. You might still mock some of them. For example, you might just run a piece of your web application with the network layer stopped. There's no network communication, just to see how the UI works. So these are integration tests. And then there are API tests. Modern applications are like a cake. They're written in layers, right? So on the back end, you might have a database access layer. Then you have your API layer. The API layer could be REST or GraphQL. That's where the clients from the browser connect to fetch information, to post new data. So you can write API tests that just call your server and assert that the server responds appropriately with right data. So there are tools like Postman, Node.js. You can write API tests in many, many languages. Writing API tests is extremely important because when something goes wrong, you want to determine quickly where the problem is. If you don't have any API tests, well, if something goes wrong, you only can say, well, the system is broken. But if you have API tests, you can say, the server responds correctly, so the problem must be in my web application layer on a client. So that quickly isolates the problem towards a much smaller chunk. And you can, for example, revert just the web client release and go back to the previous one. So API tests allow you to isolate the layers of your application. On top of that, there are end-to-end tests. That's where you take the full application and test it just like a real user. To me, this means if you're working with web applications, you start a real browser, right? At this point, we don't want any emulations. No, we want to open Chrome, Firefox, Safari, the real thing. We load real application. So we actually go into like localhost or like staging.domain or even production.com, right? Whatever, but you load the real thing. And then we interact with your application just like a real user. And that has huge number of, I would say, patterns. So for example, a user cannot click on a button if a button is not in a view in a browser, right? The user first scrolls.
Right.
So a real tool that tests a real website has to scroll first. And once you scroll, you can't just click on a button. You still have to check, is the button even visible? Is it maybe covered by a model dialog? Maybe the button is disabled. You can't just blindly find an element in the DOM and click. So the software has to really mimic the user behavior. So then you also need a large number of assertions to really check if application is working. You need assertions to make sure elements appear, disappear, the network calls are made and not. Maybe application sets a local state in the local storage in the browser, so you have to check those things. So you need a lot of assertions to make your end-to-end test powerful. The next piece is visual test. So clicking on a button, asserting that a text appears. These are called functional tests. You're testing if application functions. And that's extremely important. If your database is not responding, well, the initial list of items probably doesn't appear at all. Your application is broken, it doesn't function. But then there is a second component to your application, and that's how it looks. All the fonts and styles and layout, these are very important things. Now, the functional tests don't concern themselves with like how the application looks. If there is a button, the test will click the application's button. Now, what about the visual aspects? And for that, people write visual tests. They also call them visual snapshots. You can also hear a term like image diffing. Computers are not really smart, if you know what I mean. They don't understand if an application looks right. Only you, as a developer, or maybe as a user, can look at application and say, yeah, it looks right. But what computers are really good at is, does this application look the same as before? They're really good at comparing pixels to pixels. So the visual tests are tests where you go to a real application, you maybe interact with it, and then you take an image screenshot of a whole browser window, or maybe a part of it. That doesn't really matter. And now you get an image, a PNG, and you store that image, maybe with your code, maybe in some service. Next time you run the test, it takes again the image snapshot and then compares that image snapshot pixel by pixel, right? Like every row and column, red, green, and blue, with existing saved snapshot. And if there is even a tiny image difference, for whatever reason, it will say visually this looks different. Do you approve? Is it intended change or not? And a lot of times you catch all these errors where the layout, shifted by a couple of pixels because you changed something else on the page and it kind of shifted everything. Maybe you upgrade the library and now everything looks slightly off. Maybe you accidentally changed a CSS variable, checked one component and thought everything is fine, but that variable was used somewhere else. So to me, the end-to-end tests are functional tests plus visual tests. And taken together, they really ensure that your application both works correctly and doesn't look worse than yesterday, if you understand. Right.
Can you really drive home why managers or product owners should adopt automated testing? Can we recap on that?
Well, what do you really want from your software? You want happy users, right? The happy users are the ones that go to your website and it works, right? Now, if you manually test your website, you can miss things. And when the user goes to your website and it doesn't work, well, they probably will forgive maybe it once, maybe twice, but after that, they'll stop coming. They'll go to a competitor. Yep. I'm sure you're not doing anything that unique that your audience is locked in.
Right.
No, you can always lose customers, right? But automated testing allows you to constantly confirm that your application is working. And if you do that, the chances are higher that when the user is coming, it's going to work. And automated testing has another huge benefit. By doing a lot of tests early, that means while you're developing, right? If there are bugs or regressions, you will catch them early and the feedback cycle will be much shorter. So your developers will be like, yeah, that feature is fresh in my memory. I can fix it right now, right? So you will catch the bugs much earlier, saving your time and development money. And by the time the thing gets to production, to your users, there'll be no bugs left, right?
And even no reboot, right?
Exactly, right? And even if there is something that users discover, because users are really, really good at finding bugs, right? Almost as good as computers at comparing pixels. Users will always find a way to break things. You'll be fixing it. And the automated testing will ensure that while you fix X, you're not going to break everything you've already done, right? So that's what automated testing is for.
How do I achieve automated tests from a product owner or a manager?
You want to shift and push as much testing as possible towards what it's called left. So imagine a scale or an axis. On the left, and I'll use my left here, right? So on the left, you have developers working on a feature on their machines. They commit code, it goes to maybe your continuous integration server, right? Where things are tested again, built again, maybe deployed to staging environment where other people can test it, add more tests, right? Do other kinds of testing. And then it gets deployed to production. And that's where the users will actually use it, all the way on the right. So your automating testing doesn't have to happen only on staging or production.
Right.
You want to shift that automated testing all the way to the individual users, developers' machines, right? So that when you're developing something, you can run the whole battery of automated tests and not just unit tests.
Right.
You want to exercise your software as a whole to see if it doesn't fit, right? You remember how we talked about like integration tests where we're trying to put things together? You want to do it on your machine while you work on the part. So that's very important. And that's called, like nowadays in DevOps field, shifting left. Run as many tools at developer's machine, right? That will allow you to do the full testing as early as possible. And it will shorten the feedback cycle because you will see if the software you're working on or changing actually passes as many tests as possible before you move it down the line to the right.
Who's responsible for testing?
I strongly think that developers who are working on software should be writing automated tests. To me, the model of I'll write the software and I'll write unit tests and then I'll throw it to someone else, like maybe some other department who will assure that it passes my quality check. It's a great model, but it doesn't really work with automated testing, right? First of all, the feedback cycle is too long, right? If you throw it to someone who's on our team, they have to know what to test, right? Maybe they are in a different geographic place, maybe in a different time zone. By the time you get a response, it's already a different cycle, different day, different week. So to me, the cycle is way too long. The second is that what we noticed when you write automated testing, a lot of times you'll find, oh, my software is not testable, right? Maybe I don't know how to find the button. So I have to quickly add a selector to that button so my test script can find it. Now, if someone else has to write the test, like if a QA engineer has to write the test, they're like, I need a selector, goes back to the left, the developer will say, I'll schedule it next week, right? Maybe they'll add a selector, maybe not. And that's such a pain point. And it's almost like, if it doesn't affect me, I don't want to do it. And that's what developers will think, I don't have to write a test, so why change?
This has been the mentality, though.
Might as well ask developers to do things while they're working on the software.
If we're doing this right, we're actually at a point where we're actually operating pretty effectively, all right? I'm a manager, I'm running a team. How much overhead, how much extra expense, how much reduction in productivity for my developers do I have by including the automated testing for each of my features that I'm developing?
It's not about the time you spend writing tests that really matters. It's how much of a value does a good quality software, right, brings you. How much value does deploying the web application gives you and confidence if you know it's well tested and when the user come in, you're not going to have bugs. How much confidence do you have that when you, for example, push to production on Friday, that you don't have to have the whole team just stand on standby, right? Like kind of biting nails, right? So to me, the typical outlook that writing tests is a drag, is a chore, is a boring
that's
thing.
What I want to get. So if I can change my team's mentality, how much are we talking? 10%, 15%? I mean, we know the benefit, right? There's no rework, there's no friction. We have security, reliable user experience. How much is this going to cost us to do, right?
How much is going to cost not to do that? But like, that's the real thing, right? Like people constantly say, well, if a bugs get, basically people have measured how much does it cost to fix a bug, right? And again, on that axis, all the way from the left where developers discover it versus all the way when it gets into production. Now, the best alternative or analogy I can say, imagine your car, right? Imagine there is a faulty ignition, right? Like who had it recently, Chevy or Ford a couple of years ago. It got all the way to production. It actually caused accidents. It costs hundreds of millions for a company to fix that, because once it gets into production, it is hard to fix, right? But imagine you discovered, well, preferably during design phase or during building the phase, right? And testing it.
Yeah.
So to me, this is the same thing. It's much cheaper to invest percentage of your time writing tests while working on a feature than allow it to, kind of propagate to production. But even aside of that, I strongly feel that good tests actually speed you up, right? Yeah. That's my and unfortunately, it's very hard to measure. I don't have a number, right? But think about you running, let's say, a software agency. You get a client's project, you implement a feature, they're happy, they pay you, they come back a month later, and we say, can you implement second feature because you've done a great job? And you're like, if you don't have good tests, there is no way you can implement second feature quickly. You will have to remember how the first feature worked so you don't break it accidentally, right? You start modifying code and you constantly have to double check yourself manually. Is the first feature still working? I would say if you implement just one thing, you don't need any tests. If you never have to come back to it, don't write any tests. That's it. But if you ever plan to build a long-term relationship with someone by delivering feature, could be a client, could be users, right? You need quality. And after a while, it snowballs, and good quality allows you to move faster. It actually allows you to actually sell more things because they work. So that's my opinion.
This is such a complimentary episode to an episode we did on speed. And speed's all about building quality in. And so the message has been heard many times, right? It really comes down to, do you have the coverage needed? Is automated testing built in? You have all the test suite, all the tests you just described, are those built into the platform?
Right.
And most managers I talk to and executives, they know why they don't have the reliability, why the release schedule is slowed way down. Not only technical debt, but it breaks everything else, and there's rework because there's no tests involved. So,
right.
What's the roadmap to getting started, right? Like, what's the sequence of steps if I want to start creating an automated test suite?
So the one thing I want to suggest is look at what tests are most effective, right? I still write a bunch of unit tests, but I would say a single end-to-end test where you test the whole system like a user, right, gives you a lot more confidence. So if you're starting automated tests, it's easy to get unit tests up and running, so I wouldn't even worry, but I would try to get a single end-to-end test up and running as soon as possible. And I say start small. Don't write the test to cover all your features and then kind of try to run them. A single visit to your website just to make sure it loads already gives you confidence. Already will find so many sources of errors. So just write a test that opens your web application and confirms that it loads. So once you do that, right, you don't even have to push it into your, with your code, right? You don't have to complicate things yet. You can just still try it, maybe keep it separate in a separate repository. So you can still evaluate the tools, right, without adding more complexity. But what I strongly recommend, no matter how, like if you put it in the same repository or a separate repository, set up continuous integration to build and run the tests on every commit. So every time you change something in your application, run that simple end-to-end test, just to get in a habit. And once you see it working locally on every commit, on every pull request, once you deploy to staging, once you go to production, right? A simple test, just a load application. Then you can build up on that. Maybe you write a second test that maybe goes through like main feature of your application, right? So now you have two tests. Right. And again, they kind of run through a whole pipeline, giving you confidence that not only your application is loading, but the main feature of your application works.
Right.
And then come up with a plan. Do you want to start maybe covering every new feature as you work? Add a feature, add corresponding tests from now on.
Right.
Or do you want to go back and cover your existing features with tests? It's up to you. Now it's your judgment call. So talk to your team, evaluate where is like your priorities are, where the risks are, right? And go from there. But start small, set up continuous integration from very, very start, and then slowly expand the automated testing solution.
What are things I need to look out for? What are common mistakes that, as I'm getting started here?
So what I've seen, and we literally have hundreds of companies that use Cypress services right now. So we're talking to our clients, customers, open source users all the time. We're doing webinars together. So we kind of see, same problems, but every organization, of course, is unique. But the most common thing is trying to do what I call a waterfall model. And waterfall model is the same thing as you know from software development lingo. It's where you design everything, implement everything, test everything, deploy everything, and you're done. Don't do that. So in automated testing, this means do not write 100 tests covering everything before you run them on CI even once, right? Don't try to intricately cover everything from the get-go. Instead, start simple. Start running a single test on every commit, on every pull request, all the way through staging and production, and then build up on that. Like you don't have to write very complex tests in order to get confidence. And for me, the confidence comes from running that test at every step of your software lifecycle, from local to staging to production. So don't use waterfall model. Instead, iterate. Another common pitfall I see over and over is having a single testing guru. So imagine you have a team.
Right. We've already covered this, but yes, good point. Yeah. Yep.
Imagine you have someone who's like, I know this tool very well. I'll write all the tests. And I don't think that's right. So instead, use what I call testing mentor. Someone who knows the tool.
Yes.
It could be Cypress or any testing tool.
Yeah.
And every engineer, when they have to write a test, instead of asking someone else, how do you do that? Instead, that mentor teaches them or pair programs with them to spread the knowledge, right? To dissipate it through the team so that everyone levels up and everyone becomes, a star in the tool. So don't have someone who just has expertise in that area, right? This is not a specific skill. This is a skill for everyone to acquire. So do that. And another thing, which is kind of my personal pet peeve, but we've seen it over and over and over again. Don't write your homegrown, private, closed source testing tools. It's a lot of fun. I've written my own testing frameworks, but the difference is you should totally write them. Make sure they're open source, right? Make sure other people are using them so they discover and battle harden it. If you open source, it also will force you to document them, right? But a lot of problems I see, people or companies have internal tools that are not documented, out of date, have bugs, and the person who has written them has left.
Right.
Right? And the company has to scrape everything and say, no, we have to abandon all our time investment because nobody can maintain it anymore. Right? So don't do that. If you have an existing homegrown testing solution, look around, see what open source tools or commercial tools do kind of the same thing, and think about transitioning. You will get new features, you'll get bug fixes, you'll get documentation and support that you won't get with private internal homegrown tool. So switch to open source or commercial tooling.
Gleb, I am grateful that you took time with us today. I think our listeners are really going to find this episode really valuable. We've been talking about testing. It's not a great topic to talk about, but it's one that a lot of managers understand they need to do. And it was great to have an expert like you who lives and breathes every day to serve the development community to make testing easy, right? At Cypress, that's what you guys are trying to do. So I really appreciate you being here.
Gary, it was my pleasure. Thank you for inviting me. And to every listener and viewer, happy testing.
Okay. All right, guys. Thanks so much. And until next time.